Let's start from our last exercise in chapter 7. So here we already import an array and we find the largest and the smallest element in the array. So in this program, we will add the following. We will ask the user to enter a search number, and we will search the array, see if this number is in the array or not. Then we will sort this array. First, let's use the static value array. So we comment the vector. We use a integer value size. And we see the red one here. That means values.size. That's one of the vector method. It's not available for static array. So we change this one to size. S-I-Z-E in capital. So after the program output the smallest element, we are going to display a message to the user and ask for the number they want to search. Please enter the number you want to search. Semicolon. And for this number, that's a new variable, right? So let's declare a new variable, search num. Then we can get cin search num. It will be good if we put the cout before the cin, okay? So the book has taught about linear search and a binary search. Which one shall we use? Shall we use a linear search or binary search? So let's first use binary search to see what happens. For the algorithm, when you study, you understand it, but you don't have to memorize it. If you want to, because you understand the program, so you know what time to use it. What's their strong point, right? So we're going to use binary search. You don't have to memorize it. We can just get the code from online or from this textbook. The binary search is in the book programming book code. On the textbook, that's program number 2, chapter A. So we just copy paste this function, binary search function, and put to our source.cpp, and we can paste this function above the main. And we don't need to have a function prototype, because when the compiler first had this function, it knows everything about this function. Then in the main, when the compiler see we call this function, the compiler understand what we mean. So in this function, binary search, it returns integer, and it has 3 arguments. First is the constant integer array. Second is the size of the array. Third one is the value to search. So in this main function, we can just call binary search. And inside the code, we can see it returns the position. So position is initialized to -1. If the number is not found, the position will remain -1. So it will return, the function will return -1. If the number is found, this function binary search will return the index of the element. So in the main function, we can say integer search results. We have another variable to store the result, search results as integer, equal, because binary search is a function return integer, so we assign to search result. Then we call binary search function then we have a 3 parameter. First one is we pass the array values, then size, then this search num, then semicolon. Then we have a if-else statement. If search result equal to -1, we see out the number search num is not found in DL, else we see out the number which is in search num is at position search result, because the search result represent the index. We know the index start from 0. So if we talk about position, let's add a 1. Maybe we should say the number, search number is at array is array, then we just give a number. Okay, let's run this program, see what happens. Let me just randomly enter something. And the search number, let's enter 9. See, the number 9 is not found. What happened? Why binary search is not working here? What about the linear search? Let's try linear search. So linear search is in the book, chapter 8, number 1, right here. Let's copy the linear search and put in front of the program. The linear search is similar as a binary search. It returns integer and it has 3 arguments: array, the size of the array, and the number to search. So instead we call binary search, we can just copy and paste this line. We call linear search. And let's run. And the number, let's see, enter 9. The linear search returns the correct answer. The number 9 is at array element 8. That's right. The reason is what? The reason is binary search, there's a requirement. The array must be sorted for the binary search. Right now, our array is not sorted. So remember very carefully, binary search is efficient, more efficient than linear search, but it must be used on a sorted array. The next task is a sort array. So we can use a selection sort. Let's take a look at the code in chapter 8, number 5. So the selection sort right here, it's a return void. It's a procedure, void, selection sort, and 2 arguments. One is array, one is the size. So let's just copy this function and put into our function. So we put in front of it. And for the swap, the C++ provide a nice swap function, built-in function, deal with all kinds of overload. So swap function, the built-in function can deal with different type of a parameter, different type of array. So we just use the C++. We don't need to implement our swap function. So selection sort we call in the main program because it returns nothing. It is void function. So it is standalone. Selection sort. And the 2 parameter. One is the array, then size. Semicolon. So we call this selection sort. Then the array will be sorted in descending order. Then we are going to use for loop to output each array element. So let's say integer I equals 0, I less than size, semicolon, I plus plus. Then we can just say cout the array element. So index plus 1 is we call values at index I, then endl. So that's it. And then we can add a message before the for loop. We say cout the sorted array is the following. And the new line. And then we add an element here. So let's run. We give some number. And we search for 9. So number 9 is array element 9. Yes, correct. And the following array, we can see it's sorted. We have so many, 34, 1, 2, 3, yeah. 3, 34, 267, yes. The biggest one is 1445, yes. Seems like it's correct. So let's try the binary search. So we sort the array, then we can use binary search. So let's comment the linear search here. And let's move this code Okay, let's move the selection sort before the search section. So we sort the array first. Then we search. This time we use a binary search. So we sort the array first. We output the sorted array. Then we ask a user to input the number to search. And this time we call binary search instead of linear search. Let's see if binary search works. And we give some number. And the array is sorted. We can see array is sorted. And it asks us to enter the number. Let's enter 9. Number 9 is array element 4. Yes. See, this is sorted array. It's based on the index. Now the position is on the sorted array. It's not on the old array, original array. The array is already sorted. So 9 right now is the element number 4, which is an index 3, right? Index start from 0. For your homework, the rainfall, you're sorting the rainfall. At the same time, you need to not sort. You need to also move, swap the month name, the corresponding month name related to the rainfall. So you can use, I recommend to use the do sort in the book. The do sort take 2 arrays and the size, and it will first sort the cells and also move the ID related corresponding to the cells element